So hello everyone, we are here back again with part 3 of the video, and today's our topic is spherical mirrors. In part 2 of the video we have covered reflection of light and laws of reflection. We are in the chapter Light Reflection and Refraction, and today we'll be learning about spherical mirrors. In our day-to-day life we definitely see these types of mirror. We see the mirrors in our vehicles, we see mirrors in our parking lot, and in our society also we see the mirrors. So what exactly are these spherical mirrors? We'll be discussing about them. We will basically talk about two types of mirror. We will be basically talking about concave mirror and convex mirror, and both of them are termed as spherical mirror because they are part of a sphere. Now what do you mean by that? Let's have a look at it. So when we talk about spherical mirror is a curved mirror which is a part of a hollow sphere. So you can see this was the original sphere, and from this sphere one section is being taken out. Now this one section, when it is being taken out and the outer side is being coated. Now when we are looking at it, the inner side is polished and the outer side is coated so that it becomes a rough surface. This forms the concave mirror. You can see spherical mirror whose reflecting surface is curved inward. Whereas when we talk about convex mirror, it's the same sphere of which one section has been taken out and inner side is been coated and made rough and the outer side is polished. So spherical mirror whose reflecting surface is curved outward is called as convex mirror. So when we talk about convex mirror and concave mirror, we need to understand several terms related to the spherical mirrors. So let's talk about it. It says terms related to spherical mirrors. When we say spherical mirrors, it means these are the terms which are common for both concave as well as convex mirror. Now, there are few terms you can observe. This is pole. Basically, pole is the center of the mirror. You can see this is the reflecting surface. The center of the reflecting surface is called as pole. Whether it's a convex mirror or a concave mirror, the center of reflecting surface is pole. The center of a sphere from which the mirror is being made or is being taken out is called as center of curvature, and the radius of that sphere is called as radius of curvature. So you can have a look at it. The line which connects the center of curvature and pole is called as principal axis. You can have a look at it, and there are a few more terms which we will be discussing about them. So you can see these are some of the terms and their understanding. Center of curvature, it's the center of the sphere of which the mirror is a part of. You can see this is the center and this is the sphere. The center of this sphere is called as center of curvature. Now why are we calling it a center of curvature? Because we'll be considering only the curvature of the mirror, and that's why we're calling it as center of curvature, denoted by the symbol capital C. Next term is radius of curvature, which is denoted by capital R. As I told you, it's the radius of a sphere of which the mirror is part. So it is the radius, you can see, which the mirror is part, represented by CP, where P is pole. And pole is basically the center of spherical mirror. So as I told you, spherical mirror is valid. When we use the term spherical mirror, it means it is valid for concave as well as convex mirror. You can see the next one is principal axis, represented with the symbol XY. It is the straight line passing through the center of curvature and pole. You can see the line passing through center of curvature and pole in both the cases. And the last one is aperture, which is represented with the symbol MM dash, or you can also label it as MN. It's the diameter of reflecting surface of a spherical mirror. Now, these were some of the terms which are common for both concave as well as convex mirror. Principal focus for concave mirror and convex mirror are different. Although the definition remains almost the same, but the way they are being expressed are different. Now, in a concave mirror, the ray of light which are parallel to principal axis, you can see the rays are parallel to principal axis. After reflecting from the concave mirror, they converge or meet at a point. When we say converge, it means they are coming to a single point and they are meeting. And the point where they are meeting is called as focus. You can see that point is called as focus. So I'll repeat it again. In a concave mirror, the ray of light parallel to principal axis after reflection meet at a point on the principal axis called as principal focus. In the case of convex mirror, the ray of light which are parallel, they are not converging, they are diverging, they are going away. We need to understand what do you mean by converging and diverging. Converging is coming to a single point. Rays from all the direction are coming to a single point like this here. When we say diverging, rays are going away from a single point. So if you are observing from here, you will feel that all the rays are going away from the single point. So in convex mirror, rays of light parallel to the principal axis after reflection gets diverged and appear to come from a point on the principal axis behind the mirror. This is very important. Behind the mirror is called as principal focus of convex mirror. So you can see, as it is in front of the, in case of concave mirror, as it is in front of the concave mirror, this focus is real. Whereas in case of convex mirror, because it is behind the mirror, the focus of convex mirror is virtual. Concave mirror is also called as converging mirror because the light rays are converging after the reflection from the mirror. Whereas convex mirror is also called as diverging mirror because light rays are diverging after reflection from the convex mirror. The next term which is important is the distance between pole and focus. Whether it's a concave mirror or convex mirror, the distance between pole and focus is called as focal length. And there is a relation, if you would have just recollected, that radius of curvature is the radius of a sphere from which the mirror is made. So there's a relation between radius of curvature and focal length, and the relation goes like this, that radius of curvature is twice of focal length, or we can say focal length is half of radius of curvature. So if you know radius of curvature, you can find focal length, or if you know focal length, you can find the radius of curvature. These are some of the terms which you can observe. This is the mirror, pole, focus, center of curvature, principal axis, you can see, and this is aperture. We will also have a look at some of the questions from the textbook from page 168. Question 1 says, define the principal focus of a concave mirror. So if you recollect, the concave mirror is the mirror where the light rays are converging. So principal focus of a concave mirror, the point where the light rays are converging after reflection from concave mirror is called as principal focus. Next part says the radius of curvature of a spherical mirror is 20 centimeter. What is the focal length? So we know the radius of curvature is twice of focal length, and if you know the radius of curvature, then you can find the focal length also. So we know it is going to be r by 2, which means it's going to be 20 upon 2, which means it's going to be 10 centimeter. So these type of questions are asked when we are starting with the basics of mirror, spherical mirror. You can also have a look at the standard answers which are there on the screen. So here are the answers. The principal focus of a concave mirror is a point on its principal axis to which all the light rays which are parallel and close to axis converge after reflection from the concave mirror. And answer for the second one is, we know the relation, focal length is half of radius of curvature, so half of 20 gives you 10 centimeters. So this was all about part 3 of the video, where we have discussed about spherical mirrors and terms related to spherical mirrors. In the next part of the video, where we'll be discussing about rules for formation of images by concave mirrors. So stay tuned. And if you have any more questions, do put your questions in the comment box. That's it from my end. Thank you.